Hello again, general mathematics learners. Let's continue with our discussion on lesson 1.1, functions, an introduction. This time, we are going to identify different types of functions. We have 9: linear, quadratic, constant, identity, absolute value, rational function, exponential function, logarithmic function, and piecewise function. Let's start with the first one, linear function. Now, a linear function is a polynomial function with a degree of 1. It means that the highest exponent for the variable for x is 1. It is written as in a slope-intercept form, f of x, which is also equal to y, is equal to mx plus b, where m and b are real numbers and m and f of x are not equal to 0. The graph of a linear function comes from its root word. It is a line. Example. Let's have example for linear function. The highest exponent for x is 1. Remember, when there is no exponent for x, it means that there is 1. Therefore, this is a linear function. Next, what's the highest exponent for x? 1. Therefore, this is a linear function. We'll have a sample problem. If you will buy an egg in the delivery store, its price is 7 pesos per egg plus 20 pesos for the delivery fee. Suppose Maria buys 10 eggs. How much will she pay? Now, since we're talking of the price, then we call this function a price function. The price of the egg can be written as 7x, like 7 pesos for each egg, plus 20 pesos for the delivery fee. Since Maria buys 10 eggs, then we substitute 10 to the value of x. So that becomes 7 times 10, which is equal to 70, plus 20, That's equal to 90. Therefore, Maria needs to pay 90 pesos. Next, the next type of function is a quadratic function. A quadratic function is a polynomial function with a degree of 2. It is defined as f of x equals ax squared plus bx plus c. Its graph is a parabola. If you remember your grade 9 lesson, the parabola could open upward or the parabola could open downwards. Let's take some examples. What's the exponent for x? It's 2. Therefore, this is a quadratic function. In the next example, remember that f of x is equal to y. Now, what is the exponent for x? That's 2. Therefore, it is a quadratic function. Let's go to the third type of function. We have the constant function. A constant function is a linear function defined as f of x equals c. It means that there are no variables. C would stand for a number, a real number, where c is a constant term. It's a numerical value without a variable. The graph is a horizontal line. For example, f of x equals 4. Or another, y equals negative 10. Based on this graph, the equation of the constant function is y equals 1.5 or 1 and 1/2. The fourth type of function is the identity function. An identity function is a linear function where y or f of x is equal to x. Its graph is a line. Again, in the identity function, whatever the value of x, that is also the value of y. Example, f of x equals x, or y is equal to x. Next, the absolute value function. In the absolute value function, the x value is found inside the absolute value bars. For example, in this one, x is found inside the absolute value bar. But if x is found outside the absolute value bar, and only the number is found inside the absolute value bar, we do not call it an absolute value function. Now, since it is an absolute value, then the value of x is always positive. The graph is in a V form. Again, the graph of the absolute value could open downward or it could open upward. For example, let's go back. Where do you find the x? Inside the absolute value bars. So we call it the absolute value function. The second one, where do you find x? Inside the absolute value bars. So we call it the absolute value function. Next one, the rational function. A rational function is defined by the equation f of x equals g of x over h of x, where g of x and h of x are both polynomial functions. Its graph looks like this one. It's asymptotic. What do you mean by asymptotic? It goes nearer and nearer to the asymptotic line, but it will never cross the asymptote. For example, this x plus 5 is a polynomial function. X minus 5 is also a polynomial function. Therefore, these, with the numerator and denominator as polynomial functions, we call this whole function a rational function. Next, 4 is a polynomial function. X is a polynomial function. So therefore, this is a rational function. Now, when can a function be not polynomial? It happens when, first, the exponent is a negative integer. Second, the exponent of x is a fraction. Or the third one, if x is found inside a radical sign, like a square root of x. Next, we have the exponential function. In the exponential function, a, the base, is a number, while x, the exponent, while x, the variable, is found in the exponent. And remember, a should not be equal to 1. The graph of an exponential function is asymptotic. Again, it will never cross the horizontal line. For example, where do you find x? In the exponent. So it is called an exponential function. Next, where do you find x? At the exponent. So we call it an exponential function. The next one is a logarithmic function. It is the inverse of the exponential function. It is defined by the equation f of x equals log b of x, where b is greater than or equal to 0 and b is not equal to 1. Its graph is asymptotic to a vertical line. If we review, the graph of the exponential function is asymptotic. It will never cross the horizontal line. While for a logarithmic function, it will not cross the vertical line. For example, log 5 of x, or another, f of x equals 2 plus log 3 of x. These are called logarithmic functions. The last one is the piecewise function. This is called a function with conditions. It is a function with more than one formula or condition. It is also called a compound function with multiple subfunctions. Its graph depends on the given function. For example, f of x or y is equal to 2 if x is greater than negative 4. F of x is equal to negative 5 if x is less than negative 4. For example, if the value of your x is 0, what's the value of your y? If the value of x is 0, then it is in this condition, since 0 is greater than negative 4. So the value of your y is 2. So we say that our ordered pair is 0, 2. What if the value of your x is negative 10? What's the value of y? Here, negative 10 is less than negative 4. So we take this condition. Thus, the value of y is negative 5. What if the value of x is negative 4? What's the value of your y? The condition only states greater than negative 4 or less than negative 4. Thus, if the value of our x is negative 4, then no condition will suffice the statement. So your y is undefined. If you have any questions, feel free to chat me or to Telegram or give me a private message and I'll attend to you. Now, you may review again this video and be ready for activity number 2. What type of function? Again, good day.